So I welcome our first international speaker, Dr. Jai Govind Singh sir, and his session will be on fundamentals of sustainable energy and climate change. So before starting the session, I will like to introduce our international speaker. Dr. Jai Govind Singh sir is currently working as an associate professor in Asian Institute of Technology, Bangkok, and he has received his PhD, MTech, and BTech from IIT Kanpur, IIT Roorkee, and MNIT Allahabad, respectively, in electrical power engineering. Dr. Singh joined the Asian Institute of Technology in December 2009 and currently working as an associate professor and head of the Department of Energy and Climate Change at AIT Thailand. Before joining AIT Bangkok, he worked as a postdoctoral research associate 2008 to 2009 at the Royal Institute of Technology, Sweden, followed by the University of Queensland, Brisbane, Australia, as a postdoctoral research fellow in 2009. His teaching and research interests include power system planning, operation and control, smart grid and microgrid, electric vehicles and battery storage, deregulation, solar and wind integration, power distribution system planning. Currently, Dr. Singh has supervised 7 doctoral, another 9 are going, 74 master's graduates, beside being involved as a committee member of more than 180 committees, doctoral thesis work completed in last 15 years. It is our privilege and honor to welcome Dr. Jai Govind Singh sir as one of our international speaker for this 6 days online FDP. And this session will be on fundamentals of sustainable energy and climate change, as all of the works of him are associated with this since last 20 years. He is extensively doing research work in this area. So without wasting time, may I please request Dr. Jai Govind Singh sir to start his session. Sir, you have next 90 minutes. So the session is all yours. Please take. Please carry forward.
Thank you, Ankur, and very good evening, all of you. Okay, can you give me some moments to share the slide? Hello. Can you see my slides?
Yes, sir.
Okay, thank you. Okay, so once again, a very good afternoon, all of you. And thank you, Ankur, for introduction. So outline of this talk is related to climate change, then impacts, and then critical aspects, causes of, and then energy transition, carbon emission by countries, then emission by sectors, then sustainable energy and climate change, and then global initiatives, then what innovations required to drive the sustainable energy, and then challenges and solutions, and little about the role of AI. Before moving to our talk, so you can see here that little information about my affiliation. So I am working in AIT from more than 15 years, and AIT was founded in 1959. It is a postgraduate institute, and it has only master and PhD. It is a residential campus. We have around 1800 plus students. And then also it is a home of the 600 plus faculty staff and from 30 plus nationality. And we have two intakes, August and January. Every year we receive around 4,000 applications, and these applications are like from 100 plus countries. And our enrollment is roughly around our enrollment are roughly around 500 to 600. Okay, coming back to our climate change. So you can see that climate change refers to the long-term shift in temperatures and weather patterns. So this is a simple definition. And such shifts are part of the global, or considered part of the natural cycle of heating and cooling due to changes in the sun's activity, ocean currents, and volcanic eruptions, which usually happens over tens of thousands of years. But now Earth's climate is changing faster than ever during human history. And this trend of rising global temperature is called global warming. If we just see the left and right picture of Alaska, in last 63 years, how much changes has been happened. Earlier it was all, you can see the only snow, ice, but now it is, you see the water. So temperature, it looks like change a lot. And Earth's average temperature has increased by at least 1.2 degrees Celsius since 1880, and most of that warming has happened since 1975, means in last 45 or 50 years. Okay, so global warming is one of the ways that Earth's climate is changing continuously, where human activities are the leading cause of the climate change. Okay, so human activities release the gases that are leading cause of climate change and making atmosphere better at trapping the sun's heat and block heat from escaping greenhouse effect. Basically, these gases trap the heat from the earth and sun both, and that's why temperature of surroundings atmosphere increases, and that's why warm. So gases in the atmosphere, such as carbon dioxide, trap heat. And human activities such as burning fossil fuels releases more carbon dioxide into atmosphere. And these changes cause the atmosphere to trap more heat than it used to earlier before normal CO2, you can say, or stabilized CO2 level, and which lead to the warmer Earth. So CO2 gases includes carbon dioxide, greenhouse gases includes carbon dioxide, methane, and nitrous oxide, and other chlorofluoro and hydrogen chlorofluoro. So 5-6 gases are there. And the carbon dioxide is the most common greenhouse gas in the atmosphere. And carbon moves between the earth, living things, and atmosphere in the carbon cycle. If you remember, if you know that, okay, like I hope you know, that carbon release from earth to the atmosphere, then plantation, forest, these all consume the carbons through photosynthesis, and then it absorb in the log or wood, okay, natural plants. So those all depends upon the carbons. So that cycle keep on goes unless we extract materials from the earth and then we burn, exposed to the atmosphere, and that's will increase more than natural cycle. So the amount of carbon dioxide in air is already, you can see, the more than 50% in 1750. About like 25% change happening after 2000s, or in this century, 25% additional CO2 emitted. Methane is the next most common greenhouse gas and has about 80 times, you see, the 80 times warming power of carbon dioxide. Means 1 kilogram methane equal to 80 kilogram CO2 in terms of impacts. And you can see also how it here it was like it going cycle ups and down, but from here you can see it is going only up and up. So main source of methane are from fossil fuels use, farming, means agricultural, and waste. Okay, like whatever the waste come. So impacts of climate change. So recently, global economy has struggled with the numerous severe and enduring environmental challenges, including climate change, desertification, means increasing the desert, Registan, then deforestation, and global warming, ozone layer depletion, and respiratory diseases. So the primary driver behind this catastrophic shift in climate predominantly arises from the rising level of GHG in the atmosphere. And you see the combustion of fossil fuels energy to accelerate economic activities, okay, because we want to, our current economics model is how much growth, how fast growth, and economics, okay, which cause a 0.2 degrees Celsius temperature rise per decade, okay, per decade. And 150 billion metric tons of annual Antarctic ice melt, and which is also causing the sea level rising. 6 million hectares of yearly deforestation. and 7 million premature air pollution deaths. So these are some estimates of the global warming. And if you see the sea levels continuously rising, okay, so you see they're around 3.5 mm per year rising, almost from 1993, almost from in 30 years, okay, 30 years, almost 10 centimeter has risen, okay, sea level. Hurricanes, current Los Angeles fire, if you see, and many, the flooding, hurricanes, other places, you can see the droughts, ocean acidification, which reduce the pH value of ocean, which is dangerous to the many indigenous creatures or natural resources. So, causes of climate change. One is the generating power, generating electricity and heat by burning fossil fuels causes a large chunk of the global emissions. And most electricity is still generated by burning coal, oil, gas, which produces carbon dioxide and nitrous oxide, which are powerful greenhouse gases that blanket or cover the earth and trap the sun's heat. Okay, so these are the, you can see the things are happening. So more than a quarter of the electricity comes from the wind, solar, and other renewable sources, which like including hydro, which are opposed to the fossil fuels and which emit little to no greenhouse gas. So manufacturing and industry produce emissions mostly from burning fossil fuels to produce energy for making things like cement, iron, steel, electronics, plastics, clothes, and other goods. So mining and other industries processes also releases gases, as does the construction industry. Machines used in the manufacturing process like often run on coal or oil or gas. And some materials also like plastics are made from chemicals sourced from the fossil fuels. So these are also part of that. So manufacturing industry is one of the largest contributors to the greenhouse gas emissions worldwide. So if you see that this is iron and steel, 29%, cement, 27%, chemicals 15%, and other paper, pulp, and other industry 24 to 27%. Okay, so you can see what are the different causes of climate change, or you can say emission basically. So deforestation, like cutting down forest to create farms or pastures or other regions cause emissions, since trees, when they are cut, release the carbon they have been stored from atmosphere. Okay, so each year approximately 12 million hectares of forest are destroyed, and since forests are absorb carbon dioxide, so destroying them also limits nature's ability to keep emissions out of the atmosphere. Okay, so deforestation together with agriculture and other land use changes, okay, is responsible for roughly a quarter of the GHG emissions. Okay, so you can see the mining, fuel, forest fires, infrastructure development, logging, agriculture, expansion. So these are the agricultural expansion. It do the multiple ways. One is the you cut the trees and then you release the carbon to atmosphere. Second, by agricultural activity, use the nitrogen, fertilizers, pesticides, many other things. So then all these also lead to the GHG emissions. Other sector is transportation. So most the cars, trucks, ships, and planes run on fossil fuels. Okay, and that makes transportation a major contributor of the GHG emission, especially carbon dioxide emissions. So road vehicles, if you see, accounts for the largest part due to the combustion of petroleum-based products like gasoline and in internal combustion engines. So emissions from ships and planes continue to grow because we are going to use more and more. So if you see that transport accounts for nearly 1/4 of the global energy-related carbon dioxide emissions, and trends point to a significant increase in energy usage for transport over the coming years. And you see this is the carbon footprint of per head. Aeroplane, if you are running short haul flight means shorter duration, then 255 gram per kilometer, I think. Okay. This is medium car 192 gram. Medium car another 171 if you run the diesel and gasoline different. You see. Medium haul flight 156, long haul 150, bus 105, motorcycle 103 gram, gasoline car 96 gram, EV 53 gram. People thinking using EV is okay, is all green. No, because you emit GHG some other places in power plants, and but not on road. Okay, so but you can't count as a zero unless you produce from solar or wind purely and charge the vehicle from that. So that way, maybe it will be zero if you exclude the material and manufacturing emissions. Rail 41 gram per kilometer per head, ferry and Eurostar. Okay, so these are you can see the different emissions happening. Then producing food is another big factor, okay, which produce emissions. Like producing food causes emission of carbon dioxide, methane, other GHG in various ways. Okay, for example, clearing up the land for agricultural and grazing purpose. So that's also caused to emit. Digestion by cows and sheep or animals. Okay, they also create. Sometimes some crazy scientists telling that to kill the animals if you want to reduce the GHG. Production and use of fertilizers and manure. Use of energy to run farm equipment means agricultural equipment, machinery and fishing boats. Packaging and distribution of the foods, all these cause the emission. So if you look at in these pictures, okay, so carbon emissions from farm to table are, see the land use change, farming, animal feed, processing, transport, retail, packaging, all cause. Where 74% are non-food, but 26% are food related. In food related, you can see the livestock and fisheries are 31%, crop production 27%, and there are many other small portion of the GHG emissions in that. So if you are wasting food or energy or water, you are basically contributing to GHG emission. Of course, everything is region, but okay, some are avoidable, some are unavoidable. So if it is waste, that is avoidable, and that can you avoid from emission. And powering the buildings like light, air conditioner, etc. Okay, so globally, residential and commercial buildings consume over half of the electricity. Like you can say, like 40% energy consume. I mean, energy means not only electricity, heat, and you can say electricity and non-electricity together. Around 1/3 to 40% energy consumed by buildings. So as they continue to draw on coal, oil, and natural gas for heating and cooling purpose, so they emit significant quantities of the greenhouse gas emission. So growing energy demand for heating and cooling with rising air conditioners, everyone want to buy air conditioner and more houses are being built. So increment of the electricity consumption for lighting, appliances and connected devices has contributed to a rise in the energy-related carbon dioxide emissions. So you can see the how much it historically and now the how it is increasing, and they are different sectors. Okay, in the buildings. Then climate change mitigation and adaptation. So adaptation is you see that this is a climate change mitigation and this is climate change adaptation. So you have to work on both front. One is how to minimize, mitigate, and another already climate is change. So how to adapt with the new changes or global warming. Okay, so impacts will be less, losses will be less. So that's the adaptation. So adaptation process of ongoing adjustment in response to observed and projected climate change impacts. For example, cities could adapt to rising sea levels by building walls or using pumps to prevent flooding. I mean, this is one example. Similarly, many other, or you can say strengthening urban planning processes so that they contribute to building climate resilience. Okay, so building is more climate resilience. So that's the adaptation. And similarly, you can see here, okay, you have a disaster and emergency planning, green infrastructure, social cohesion and equity, flood protection, resilient building design, and you have a building infrastructure, drought proofing, water and energy conservation, smart energy system, trees, local food. So these all comes under the adaptation. And mitigation is here, and some common comes under both. So next is the mitigation, which means reduce the emission, okay, and stabilize the level of heat trapping greenhouse gases in the atmosphere, like prior before the industrialization era. So examples of that are like use solar or wind or both instead of fossil fuels and generate electricity from other sources or heat energy from other sources. Okay, so that is comes under the mitigation. So avoid food waste, solar power, walking and riding bike, wind power, EV charging. So these are things comes under mitigation. Now, actually, global finance is more coming to the climate adaptation. Mitigation was also, it was a main topic, hot topic there, but now adaptation is the quite dominating, but mitigation is also going on parallelly. So in terms of many activities, you can see that, okay, here again mentioned, so adaptation, forest protection, land use changes, relocation, infrastructure design, flood mitigation, emergency response, community engagement, resilient urban transport. And you have also energy access, energy security. These are comes under mitigation and adaptation both. Okay, so pure mitigation is you can use the combined heat and power plant where efficiency is very high. Like after producing electricity, rest of the heat in the exhaust can be used for the water heating, food processing or other space heating or any other even cooling like a chiller plant, etc., can be used. And low carbon transportation, methane capture and use, and industrial process improvements and carbon sinks like carbon capture and sequestration. So these are the different techniques to reduce. Then you have a energy transition and climate change. Okay, so process of reducing GHG emissions to net zero, also called decarbonization of energy system. Okay, and reducing energy-related CO2 emission and restricting global temperature rise to within 1.5 degree pre-industrial levels with requirements to reduce the climate change. And energy efficiency represents a significant, you see, the 40% abatement needed by 2040 according to IEA. So it means if you see here, you have a clean fuels, one option for energy transition, then energy efficiency second, conservation and reduction, and then carbon capture. Okay, so these are the four major ways for the energy transition. Okay, so of course we have a common target like 2050, but not going to happen. I mean, carbon neutrality. Many countries plan, even Thailand planning by 2050 for the carbon neutrality and 2065 net zero emission. So increasing the share of low carbon and clean fuels. Okay, and carbon capture can reduce the GHG by 13%. Okay, this carbon capture can reduce by 30%. Okay, and of course, efficiency can represent 40%. So these are the different ways to do that. So in simple terms, energy transition is like a transitioning from fossil fuel-based energy to clean energy, which is like energy transition. Okay, so process in which clean energy sources replace conventional energy sources to achieve energy efficiency and green environment. Okay, so you can see that in beginning, okay, earlier, let's say 50 years back, mostly used was crop waste and dung, cow dung, okay, then wood, then charcoal, then coal, okay. So these were the solid fuels, okay. So this is also energy ladder. Then move to the little more efficient clean energy, kerosene oil, ethanol, methanol, gas, LPG, natural gas, electricity. So these are the like mostly traditional biomass, and then these are the fossil fuels comes. Okay, and electricity is now coming from both fossil fuels and renewable sources, depending on that. So this is also energy ladder and energy transition from one level to the next, efficient and clean. Okay, efficient and clean level of the energy sources. Then history of energy transition. It is not energy transition is happening now because of the climate change. It has been over the past 250 years, okay, happening. If you see the, okay, like energy transitions have occurred repeatedly. The rise of coal, okay, so because of coal you had a steam engine, then again explosion of oil in the 20th century, okay, then you got a car and okay, gasoline car, and then nuclear energy in the mid of the 1950 and 1960s, okay. So these were the various level of the energy transitions happening from past 250 years, okay. You can see here, okay. So technological innovations were the catalyst of these energy transitions. The innovations of gas-powered automobiles and assembly lines all required more efficient energy fuel. So the structural change in global primary energy, okay, happening. Like the present energy systems has become more diversified, okay, and in 2022, renewables such as wind, solar, and geothermal represented around 15% of total electricity generation, okay, in 2022 global, okay, with annual growth rate of around 15%. The amount of electricity generated by nuclear dropped by 4% globally because of many nuclear plants phased out in the Europe and other West developed countries because of particularly after 2011 Fukushima crisis and some other disasters. So still, coal is the major part of the source. Then oil, you see that no, oil is the first, okay, 32%, then coal 26%. Then you have natural gas 23%. This is also fossil fuel, okay. So altogether, you see the how much most of the energy comes from the still fossil fuels. Very less energy comes from the hydro, other renewable, and nuclear. Okay. So China and US are responsible for almost 47% of the energy. And okay, so okay. Now, if you look at yeah, China and US 47%, then fossil fuels accounted for around 80% of the total energy mix. So if you see the left side figure, okay, you see India is here around here. This is the US, and this is the China, and this is rest of the world. Other major economies are given here, okay. But you see the here China and US are most responsible countries. And also, if you see, yeah, here you can see the global emission by country. So you see that China is the most 31%, then India 7%, US. Second is the US 13.5%, then India, then Russia, and then many other countries, okay, Japan and so on. So you see the how in beginning in 1950, US and Europe, two were the major economy for the GHG emission. And they continue, but later on in from last century, I can say in this century particularly, China become the major, then Asia, then US, Europe, and some other countries. So if you look at total GHG emissions now reached to the altogether, if you look at it, it is almost 57%, sorry, 57 gigatons, sorry, 57 gigatons of CO2 emission equivalent in 2023. Okay, in 2023. So it is 57 gigatons, which is 1.3% up from the 2022. So energy used in sector-wise makes 73% of the GHG emissions. If you see the all energy usage, and transport sector accounts around 15%, then power sector 26%. So energy resources are found in the environment. Now come to the energy. So energy resources are found in the environment. So there are two types. One is the renewable, where solar, wind, geothermal, biomass, etc., and non-renewable fossil fuels. Okay, and they are finite, and they can actually in some estimates it is projected that by mid of this century will be highest availability of the fossil fuels. After that, overall fossil fuels will start declining, depleting slowly. Okay, so, but demand is increasing exponentially. Okay, so what are the way to counter this issue? Already there is a gap between availability and demand. So how to meet that demand, extra demand? Okay, and sometimes the requirement increasing and then availability decreasing. So there are three ways. One is the conservation. Conserve the energy means improve the efficiency, also reduce the waste of the energy. Second, you can produce more renewable sources. So renewable sources are wind, hydro, solar, biomass, geothermal, okay? And non-renewable we have all traditional. So what is sustainable development? So sustainable development is a strategy of driving growth while using resources efficiently. So this is simple definition of sustainable development. Okay. So it takes into account the consideration the immediate and long-term well-being of our environment and people together. So three pillars of the sustainable development are economy, the efficient and responsible use of resources results in long-term profitability and business viability. Then you have environmental pillar where need to reduce waste and carbon footprints while maximizing energy efficiency, which helps to reserve negative impacts on the environment such as pollution and global warming. And third is the social. So focus on initiatives like employee safety, wellness, and diversity and inclusion supports the creation of healthier community that can sustain themselves. So this is a social progress. We have economic development progress, environmental protection and enhancement. And there is a common where each one encounter together, and that's called sustainable development. Okay, so this is the sustainable development where you have all three factors responsibly. So it means this diagram shows if you are going for economic development, then maybe you hello. Hello.
Yes, sir. I'll request everyone to just to mute yourself.
Yeah, can you mute that guy if not asking a question?
Please mute yourself.
And after
Yes.
sustainable development, now next is the sustainable energy. So
No, sir, you can unmute yourself.
okay, can you hear me?
Yes, yes.
Okay, thank you. So sustainable energy is produced and used with minimal environmental impact and does not deplete finite natural resources. This is the definition of sustainable energy. So it does not mean that it will have a zero environmental impact. It will be minimal as much as possible and does not deplete. So that's the sustainable energy. And sustainable energy is the key to the transition to a new energy model capable of addressing three global challenges, for example, environmental conservation, energy security, and socio-economic development. So the current energy and climate challenges make the transition to a sustainable and renewable energy model increasingly necessary. And sustainable energy plays a key role in decarbonizing the energy supply, reducing dependence on fossil fuels as well. So these are the like a different type of wind, geothermal, hydro, biomass, and solar. Okay. So where biomass we have a limited, hydro also have a limited, geothermal very, very less, but solar and wind are huge. So these two sources are huge in availability, and but we need to have a harnessing technology and mechanism, and even utilization is another big challenge. So expanding the use of renewable sources can contribute greatly to achieving sustainable energy, particularly because they can be sustained for very long time periods and have very low environmental emission and impacts. And energy storage can be used to mitigate the challenges of intermittent renewable, the solar and wind, and by allowing them to harvest it when available. So storage is a requirements, but okay, it has own challenges because of the cost and another environmental problems if they are manufactured as a battery storage. So then you have a plastic and many things. Okay, but you can use other storage options which are less problematic to the environment. For example, heat energy, cool energy, heating energy, like you heat up some materials and you can use that heat for later usage. Then similarly, you can convert to the cold storage, for example, ice, snow, ice. So you can convert ice into, when you have more renewable available, you convert to ice, and later on you can use in chilled water pipe to cool the space. So many other you can say more sustainable storage. For example, you can say more environmental friendly storage is required to use to utilize renewable. And yeah, so that's district heating systems, also solar thermal energy, biomass, and geothermal. Efficiency is another, loss prevention and waste recovery, energy supply and demand balance. So these are the number of measures need to take to enhance the sustainable energy. Now, sustainable energy in combating climate change. How? So what are the measures? Okay, how you will take different ways, then you can combat climate change means mitigate the climate change, reduce the impacts, basically reduce the emission. So this is you can see that in 2010, industry production emission, power emission means electric power, district heating, transport, buildings. Okay, you can see now. If you take different actions like renewable energy, energy efficiency and others, and electrification of heat and transport, if you take these actions, so basically in a normal 33 gigaton emission in 2050 in reference case, so if you take these actions, then you can reduce basically to 9.8 gigaton in 2050 by if you can reduce basically 70% emissions through these activities or these actions. So these are the actions required. So if you see sustainable energy and climate change, how possible? So emission reduction is you have to do by switching to renewable sources, energy efficiency, and transportation electrification means convert to the EV, so not to use the oil and gas. So that emission reduction mitigation. Then second, you can reduce the impact of climate change adaptation, enhancing energy resilience, microgrids, demand response. Then you have a carbon capture and storage. So you can capture carbon from the power plant or from the environment, atmosphere, or from any other production or you can say emission sites. You can store and capture and store and maybe can reuse some other applications or you can dump in the earth somewhere inside. Transport and storage, negative emissions, okay, and then policy and international agreements. The Paris Agreement, COP26, and other, and national climate policies and international collaboration. So these are the, you can see, four ways for the sustainable energy and climate change. Then you have a global initiatives, okay? So and agreements. So sustainable development goals means 17 sus- uh, 17 sustainable goals were adopted. Okay, in where we are more concerned with the this affordable and clean energy 7 SDG 7. Okay, so SDG 7 is our main focus. Okay, of course it interlinked with the other SDG as well, but you can see the climate actions, responsible consumption and production, okay, and clean water, sanitation, and there are many things are interlinked, but okay, our main is the SDG 7, okay. So SDG 7 means access to the affordable, reliable, sustainable, and modern energy for all by 2030. But look like that targets are milestone not going to achieve. Has a strong connection with the majority of the SDG. So energy is central to fostering the pathways necessary to keep the world well below 2 degrees Celsius of warming and meet a wide range of SDG targets. So pathways to limit the global warming to 1.5 degree immediate or 2 degrees required rapid and extensive transitions in all sectors. For example, energy, agriculture, urban infrastructure, buildings, transportations, and industrial systems, all were need changes in terms of energy transition. Then, if you see the global overview, so reduction of nearly 37 gigatons. If you see the earlier, we had a, okay, here, here, around reduction, okay, 33 are different projections giving different. So 37 gigatons of annual emission by 2050 can be achieved by like using renewables, hydrogen, sustainable biomass. Okay, for example, you can see 25% you can reduce from the renewable based, another 25% from the efficiency, and another 20% electrification of the heat industry and so on. 10% through hydrogen and 6% from the, you can see the other renewable based other like CO2 removals, etc. And if you see, of course, last mile use of carbon capture storage is also very, very important. Okay, so you can see that I mean, if you have this one, so if 2022 gross electricity generation was mostly fossil fuels, 61%. Then renewables 29%, 9% nuclear. And then renewables here, fossil fuels, renewables. And if you want to go 1.5 degree Celsius scenario, then you have to have a this you see the like now we have by 2022 like 3,400 gigawatt installation. By 2030 we need 11,000 plus. By 2050 we need 33,000 plus gigawatt installations. Okay, renewables. So you can see the investments. We need $47 trillion of investment, cumulative investment by, you see the 2024 to 2030, if you want to achieve the pathways of the decarbonization. So it is huge investment. I think this is not possible to get. I mean, it is quite infeasible in terms of economics and finance and also technology and deployment. So what are the innovations which are driving sustainable energy? If you see, you have a system operation. So you have a operation of a decentralized system, value complementary in renewable generation. Then we have a electrification of wind use sectors. So these are the like system operation you have to do. Then enabling technologies, you have a digitalization is a very, you can say, backbone of the all transitions. Then you have hydrogen, blockchain technology, storage, and then electric vehicles. These all are going to play enabling technology in the sustainable energy transition. Then you have a business models. Okay, what are the different business models? Like energy as a service. Okay, no more as a privilege. And peer-to-peer electricity trading means a small energy also should not waste. It should be utilized by someone or by some means. Okay, so any amount of energy should be able to sell and buy rather wasting. And aggregators means they can generate small sources, even small loads, demand, and they can aggregate and they can sell and buy. In the finally, a market design is another big player where it encourage the flexibility, because you know the renewables, mostly solar, wind are flexible, but you need a constant supply. Okay, so to make constant, you have to have some flexibility from other sources where they can cut or add or drop. Empowering consumers so they can increase, decrease as the generation increase, decrease. Value is spatial complementary also. These are quite extensive topics. We do not have time to discuss. So now, sustainable energy, what are the barriers and then solutions? Okay. So if you look at in terms of the barriers, so there are three categories of the barriers. So one is the enabling infrastructure, okay, which are like insufficient infrastructure to connect renewable energy to markets, okay. Insufficient infrastructure to connect renewable energy to markets, including storage and integration. Lack of readiness of the distribution infrastructure, for example, electricity, gas, fuels, and unpreparedness of end-use sector facilities like to switch the renewable. So end-user sectors are also not ready to switch to the renewable easily. Many small industries, factories, manufacturers, or many other applications are not ready to switch. Then you have a policy and regulation barriers, like policy regulatory framework that are still set around fossil fuels. So they are trying to change to the renewable based or more clean energy based, but still it's taking time because most of the things are fossil fuel based design, century old, or you can say more than century old design, which are offering insufficient public funding for energy transition support. Also, lack of integrated planning for energy production and consumption. Insufficient attention to the socio-economic dimension, including lack of industrial policy for viable supply chains. And if you see another big barrier, okay, out of these all are skills and institutional capacity. Basically, we do not have a line. It is all misalignments between fossil fuel job losses and renewable job gains. We do not have alignment, okay? And gaps in skills due to inadequate education and training opportunities, uneven access for women, youth, minorities, and unmet reskilling and upskilling needs, also lack of awareness of opportunity. These are the other things. Job quality issues, including wages, occupational health and safety, and overall workplace conditions. So these are number of, you can see the barriers in sustainable energy transitions. Okay, I categorize are grouped in the three: enabling infrastructure, policy and regulation, and skills and institutional capacity development. So what are the solutions in these three broad category of the barriers? So solutions, if you look at in terms of the enabling infrastructure, so you have to have a forward-looking planning, modernization and expansion of supporting infrastructure, both on land and sea, to facilitate the development, storage, distribution, transmission, consumption of renewables. And also infrastructure should facilitate national, regional, and global strategy for new supply dynamics. And in terms of the policy regulation, design the policy and regulatory framework that facilitate deployment, integration, trade of renewable-based energy, improve socio-economic and environmental outcomes, and promote equity and inclusion. And these need to enable energy transition at various levels, from local to global, and reflect new supply-demand dynamics or supply chain. In terms of skills and institutional capacity, which can solve the other two barriers, other two solutions depends upon this, like awareness and capacity building of institutions, communities, and individuals to acquire required skills and knowledge to drive sustain the energy transition. So this will include like coordination between educational institutions and industry, strengthening institutions' social dialogue and collective bargaining, and help bring all together like a greater socio-economic benefits. So these are the solutions. So you see it again are broad topics. If you go each one by one. Okay, so looking all these, so at AIT, we are from 1979 working on the renewable energy and transitions. Okay, so our focus is mostly energy, sustainable energy transition, and yeah. So our program name is also called Sustainable Energy Transitions. If you look at the courses we have designed, okay, how we do from last 45 years, we are contributing toward the energy transitions. We have around, so far, master and PhD, okay, 2000 plus graduates from more than 30 plus nationality country, okay. So you can see almost all continents we have our graduates, okay. So you see the some of the courses: energy technology transition and sustainability, energy access in rural and isolated area, smart energy buildings, energy and GHG emissions accounting and modeling in cities, economics of clean energy transition. These are the power system related: microgrid design, control, transmission and distribution system design, energy system economics and policy, bioenergy, energy efficiency, smart grid, and variable renewable energy integration. Basically, I teach these courses, this and this I teach courses, and also I teach this one, and also I teach this one. Impact of evaluation of energy interventions, power system restructuring and economics, AI applications in power energy system, energy storage, solar electricity system design, installation, performance evaluation, energy demand and pricing, electric and hybrid electric vehicles. So these are the courses we have designed, taught by 4, 5, 6 faculty from the different nationalities. And this is just my few students' thesis work. Just I listed what are the things I'm working. If you look at, say, comparative analysis of energy production using agrivoltaics, a case study of agrivoltaic system in US, Thailand, Bangladesh. global experience of development of battery swapping standards and regulation for Thailand. Cost benefit analysis by smart meter installation in Cambodia. Barriers and opportunity of EV deployment in Myanmar. Clean energy technology and cross-border power trading on electricity price and emission reduction potential from power sector in BIMSTEC region. So we are not working just country by country, also regional level, BIMSTEC region, ASEAN region, South Asia. Okay, so but this all regional also we work on that. Okay, power system modeling, anomaly detection, power asset management, AI application, peak load management, estimation of EV's daily load profile in metropolitan of Thailand, Cambodian power sector modeling, optimal energy strategy of EV in peak load integrated system. So these are some of the things, okay. Just I'll try to mention here. Yeah, we have a number of scholarships to study in AIT. We have a master's scholarship and doctoral scholarships. So who has a good CPI, they can even apply if they are interested. Role of AI in energy transition and climate change. If you look at how AI can play the role, we are coming now almost end of this presentation. So how AI can play the role? Okay, so it can play the role in planning by production line optimization, so more efficient optimization in production, efficient multiple battery usage, proactive geospatial monitoring, it will come here, okay, in computer vision, routing of EV charging points, then robotics, drone powered fault detection. You know, in transmission line, distribution lines, the drones can detect some of the things issue, even repair maintenance. Solar cell production, more robotics usage, so less fault, less manufacturing defects. So more sustainable, more life of the solar panels and more efficient solar panels will be designed. Hydraulic turbine welding, which is a robot can do better than the manual or mappings. Then you have a machine learning, real-time control of EV and charging, then electric grid management and failure prediction. You can predict the failure by observing and monitoring some data and by using data analytics. And computer vision, defect classifications, solar potential, geomapping, proactive geospatial monitoring. So these all you can see the how possible to utilize the AI to improve these things. So AI is also a big player in the energy transition. Just few examples, some things I'm going to repeat, but already I have mentioned broadly. So like industrial robots, robotics in manufacturing can seamlessly integrate with other digital technology such as AI, data analytics, and IoT, enabling real-time data collection, analysis, and optimization of manufacturing process, leading to improving efficiency, predictive maintenance, and data-driven decision-making. And also it will reduce the material losses in manufacturing and supply chains, okay? And also AI will lower the carbon emission intensity and improve the environment through the enhanced energy efficiency and energy intensity. Like total energy consumption in production of one unit will be less because of use of AI. So other things you can see in renewable energy systems, AI can utilize data to monitor malfunctions and repair potential defects on time. Okay, ensuring smooth operation of energy systems, and so it improve the energy transitions. Also, it can improve the energy companies which can store, process, and manage data more time and cost efficiently. So implementing innovative technology will improve the energy industry, become more competitive in this scenario. And also energy forecasting is essential for energy providers to predict changes in renewable source, demand, system overloads, and possible failures. It can precisely predict. So these things also have AI. And also like resource management, which can supported by forecasting, energy suppliers will be able to better despite their resources, prepare for demand in advance, predict problems, and save resources. Also, it can predict the failure and prevent the failure by monitoring properly. So energy company help to transition from the reactive to predictive maintenance. So downtime will be less and it will be more productive. Energy trading you can do by using AI, evaluate the potential risk, assess the market volatility, compare the different scenarios, and suggest a decision which can maximize the benefit out of the market situation. AI with blockchain, the also help to peer-to-peer energy trading. Okay, small amount can also trade it. So that way everyone will be also empowered through energy selling and buying. The smart grids will be another power generation distribution respond dynamically, okay, and use an AI can better way prepare for sudden peaks in demand and redistribute resources in the event of equipment failure. So generative AI also, the now another things coming, though it is a small subset of the AI, but generative AI is also more useful, like big data driven models. Okay, we're generating output based on massive training data sets, neural networks, deep learning architectures, trying to recognize small scale and overarching patterns and relationships in data sets. So generative AI is powering energy efficiency and sustainability together. So there are several models of Gen AI. Okay, I'm not going again. It is a big topic, like generative adversarial networks, variational auto encoders, and so on. So right side, you can see how it can optimize energy distribution, predictive maintenance, infrastructure, renewable energy integration, demand forecasting, and emission reduction strategy. And in climate change, how it can help? Use of satellites, drones, and ground sensors to measure the GHG emissions. Okay, and then process and analyze raw satellite imagery and other data at scale in near real time and combine input from multiple satellites, okay, which can automatically detect methane plumes from space, improve methane emissions monitoring and abatement, and also integrate the satellite information with the data generated by other types of sensors to build multi-scale monitoring and reporting systems. So model and monitor CO2 emissions with high spatial and temporal resolutions possible. Also process radar and optical satellite imagery to survey forestry and build a strong monitoring, reporting, and verification architecture around carbon offset tasks. Even the expansion of the urban population, urbanization, we can control where it is better and where it is more climate change adaptable. Okay, so you can do that one. Now I'm measuring the daily amount of vehicle traffic on roads over large regions and GHG emissions that these vehicles also collectively produce. So you can also do, you see the here, okay, so you can see the where large vehicles are gathering. So you can then modify the traffic conditions and road build and so road infrastructure that area to avoid the frequent traffics. Okay, so that is also another way. And of course, the now they are using different ways, okay, crowd management, etc., etc. So there are a lot of use of the AI. Thank you very much. So please let me know if you have any questions.
If any question from anyone end, can ask.
Hello.
Yes.
Good evening, sir.
Yeah, good evening.
Sir, my question is that how can AI help policymakers design equitable and sustainable energy strategies?
So I think we have a discussion here. Okay, you can see the here. Can you see? Can you see the
Sir,
slide?
yes, sir. Yes,
Okay,
sir.
so it should include the regulatory frameworks that facilitate deployment, integration, and trade of renewable based energy. Because the problem is, if you have some energy, let's say electricity, you have a 1 kilowatt solar panel installed for your house, but you are not there at daytime because of some office work and so on, you close, then you cannot use that maybe if you have battery storage, then you can store, but if battery is also full, then it is waste of the energy, so you cannot sell. So policy is not still, I mean, that level, you can say slowly
Okay, sir.
coming, slowly coming, but okay, still, so enabling policy level, then technology level, those are all enabling things need to come. That's okay. Is it okay?
Okay, sir. Thank you so much.
Okay, thank you. Okay, any other questions?
Any other question, please?
Hello, sir.
Yes,
Hello, sir.
yes, please. I can hear you.
Yes, sir. What types of career opportunities that develop in future for our students in this particular subject?
Okay, you see that I think you have to little modify the traditional trends, okay, which is now little become obsolete for a while. So more like you see the enabling technologies, and okay, also not just technology, also skills which are even policy economics level. Okay, so technology, policy, and economics. So these three uh, uh, components in each student should be built. Like what I can tell you, AIT, we have you see the courses, okay? I don't know, you can find these are not traditional courses, okay? So we impart the knowledge to each students a standard level of economic sense, then policy sense and technology sense. And after that, students grow, or you can say they carry on in their interest of the area. If someone interested more in policy area, they go in more policy aspects. If someone interested in the economics aspects, energy economics, they go in more energy economics, and similarly energy technology. Okay, so a minimum level of interdisciplinary, some aspects you have to provide to them, and then you have to provide the specialization. Of course, it is not only interdisciplinary everything. Okay, so some interdisciplinary knowledge, and then specific, you can say, specializations. And of course, I think there's no need to say that what are the new things are there in market, so that you can include. I don't know.
Yes,
I answer to your question. Huh?
yes, yes. Thank you, sir.
Okay, I can tell you. I am core electrical background, okay, from master to, I mean, bachelor to PhD, okay. But I'm teaching this course because you see that this course is smart grid and variable renewable energy integration, okay. This semester I'm teaching. In my course, students are from mechanical, civil, electrical, even business background, okay. So not necessarily they have electrical background, and I teach without voltage and current. Okay, after joining AIT, after a few years, I realized that just teaching core is not the theme of the AIT. So more interdisciplinary. So you can see when I teach the microgrid design of, sorry, this microgrid. Also some non-electrical background people take it, though some electrical components are there. So these are the things, of course, some are the core. Okay, you can see the number of आठवीं number का course. Okay, it is quite electrical. Six is also electrical completely. And then, yeah, only these two courses, 6, 8, 2 are the courses look like completely electrical core. Rest is quite interdisciplinary. So we have to adopt like this way. Just going same traditional way is not good for a student and even for faculty as well. So have to little diversified yourself, okay? Have to add some dimension, but keep in mind not to lose your mainstream specialization. Okay?
Thank you, sir. Thank you.
Okay, thank you. Any other questions?
I guess this was from the our first speaker end. So thank you, sir. Thank you for accepting my invitation on a very short notice. And whenever I need you, you are always there. So a special thank you to you. So uh, it was a great listening to you because I was throughout listening to your all the PPT, and it was very enriching. So thank you so much. And our next speaker is waiting for the next session. So once again, sir, thank you.
Okay, thank you very much, and all the best, Ankur. For I wish you all the best for this to successfully complete. And thank you all speakers and participants. Thank you all. Okay, good night.
Good night, sir.
Thank you.
So our next session was about to begin from 8 p.m. It is scheduled from 8 p.m. So can I know whether we want a 10 to 15 minutes break, or can we start, as I guess our speaker has joined. Can we begin with our new session?
Yes, sir, definitely.
Okay. Dr. Pawan Kumar Mishra, can you hear me, sir? Meanwhile, he is joining. We can wait for next 2 to 3 minutes. He is just joining.